This is the project of Group 444, and our team consists of 5 members: me, Hamza Jawwad, Nurkhan, Isfandiyor, Teham, and Aditya. Together, we created a secure and easy-to-use password manager. Project is basically a simple but secure password manager that lets users store, view, edit, and search their passwords all in one protected place. Everything is encrypted, and it even includes extra features like checking password strength, generating strong passwords, and saving or loading encrypted data from a file so that nothing gets lost. The whole idea is to give users a convenient, secure platform to store their passwords on. The scope of the project is to keep things straightforward. A reliable system that protects users' data on their own device. It focuses on adding, editing, searching, and validating passwords while ensuring that only the authenticated user can access their information. Overall, the goal is a safe and easy to use password manager without unnecessary complications.
Hello, my name is Davronov Isfandiyor. I will tell you about the first part of our project and why it's important, which is encryption. This code implements a basic system for encrypting and decrypting passwords using the cryptography library and its Fernet module. The encryption section of code is critical because it protects all stored passwords from being exposed in plain text. Without encryption, anyone who gains access to your file or even your Google Drive could immediately read all saved passwords. Here is what makes this part essential. The Fernet encryption algorithm securely transforms a password into an unreadable encrypted string. Even if a hacker obtains the file, the data is useless without the encryption key. Only someone who has the correct key can decrypt and read the actual password. This prevents unauthorized access.
My name is Hamza, and today I'll be explaining how the authorization system in our project works, focusing on registration, login, and how our data is saved. When a user registers, the program asks them to create a username and password. We also included a password generator feature that can automatically create a strong, secure password for the user. Along with that, the system checks the strength of any password entered and lets the user know if it's weak, medium, or strong, helping them choose a safer option. Once a user has created an account, they can log in by entering the same username and password. The program checks the stored information and grants them access if the details match. All user data is saved in a JSON file, which acts as a simple storage system for our program. It keeps everything organized and easy to access, allowing the program to remember user accounts each time it runs.
My name is Teham, and I am going to show you the part of the program that handles the main menu and account management, which is the core of the entire password manager. This section of the program is where the user interacts with the most. It ties everything together by calling all the functions which are previously defined in the program, such as encryption, password validation, data storage, and account retrieval, and provide a clean, simple interface for managing all the credentials. Once the user successfully logs in, they are taken to this main menu. This menu is the central control hub where all the password-related tasks happen. The screen displays 7 options: adding accounts, viewing encrypted passwords, viewing decrypted passwords, editing accounts, deleting accounts, searching accounts, or logging out.
Now let's take a look at the accounting section of the project. This part is responsible for managing all the user's saved login information in a secure way. First, we have the add account feature. Here, a user can enter details like username and password before saving it in the system. The system automatically encrypts the password using the Fernet encryption key. This ensures that even if someone gains access to the stored data, they cannot read the password without the key. Next, we have view accounts encrypted. This option shows the raw data that is stored inside the JSON file, including the encrypted passwords. It mainly useful for demonstrating that the system does not store any password in plain readable text. You'll see long strings of characters instead of real passwords, which is exactly what secure storage should look like. Finally, there is view accounts decrypted. In this mode, the encrypted passwords are safely decrypted using the same key and displayed back to the user in their original form. This allows the user to retrieve their actual passwords whenever they need them while still keeping everything protected. So overall, the account section demonstrates both security and usability, encrypting sensitive data when storing it, decrypting it only when users require it.
As we have already talked about adding and viewing stored accounts, let's move on to the next three options. The edit option allows the users to update the username or password of any saved service. Again, passwords must meet strength requirements before being updated. The delete option completely removes an account from the storage file. This is helpful when a user no longer uses a service and wants to remove it from their password manager so it doesn't become clustered. The search function lets the user type a part of the service name. For example, typing Insta will bring up Instagram. This is useful when the user has many accounts saved. Finally, the logout option simply exits the menu and closes the manager.
Hello everyone, I'm responsible for the utility functions, and our goal is simple: ensure every password we handle is strong and unique before it gets encrypted. Password strength validation, the gatekeeper. Our first tool is function isStrongPassword acts as a gatekeeper. It stops users from storing simple, guessable passwords, preventing brute force attacks. We enforce 4 complexity rules. That is minimum 8 characters, uppercase, number, and symbol. Strong password generator, true randomness. Our second utility function, generate strong password, eliminates human error. Our generator creates passwords with high entropy, making them mathematically impossible to guess or be under dictionary attacks. The generator is then run through the validation to guarantee the 4 strength rules are met before the password is given to the user. In short, the utility part is the first line of defense. We ensure we are starting with a virtually unguessable password before it gets passed along for deep encryption.
Come to the end of our demo. Our password manager works smoothly and accomplishes all the basic function it was designed for, but there is still plenty of room for improvement. Right now, once a user logs in, they can access all stored passwords, which is convenient but not the most secure. In the future, we could strengthen the system by adding features like restricting access to only one selected account at a time, adding multi-factor authentication, or even exploring more advanced options like biometric login. These upgrades would greatly improve privacy and security, helping the password manager move from a simple tool to a more professional level application.